welcome everyone to BayPiggies. This is our first meeting of 2021, and I guess it's online, as you know, and I guess we'll keep it online until it seems like it's appropriate not to be online. But thanks for coming. So tonight we're going to have a lightning talk and then a full talk. So Chris Brousseau is going to give a talk on data analysis on the election. And he's been a frequent contributor to BayPiggies and to PyBay, and he gave a talk, I think it was last year, on data visualization. That was really great. So we're looking forward to his lightning talk. Wesley Chun, who he may have just stepped out for a second, but he is a longtime Python contributor. He's a fellow at the Python Software Foundation. He's written a series of books on Python. I think it's called the Core Python series, and he's a developer advocate for Google Cloud. So he's qualified to talk to you about both Python and Google Cloud, I think. And so it's great to have him back to BayPiggies.
Okay, so hey everyone, I'm Sherry Eskenazi. I just want to give you a quick announcement to let you know about a unique beginner Python book I'm writing called A Day in Code Python. So it's a picture book that teaches Python by telling a continuous story with Python programs that describe real life situations. And so the code examples that make up the story teach the basics of Python. And so it's set up so that there's a code page on the left that shows a complete Python program. And there's a code explanation below it, and there's a high-level description of the situation at the top of the page. And the illustration on the right side of the page shows the situation that's being described in the code. And so my goal for this is to create a fun way to learn the basics of Python, as well as to create a convenient reference to look back on for simple and fun code examples. And so I had this on Kickstarter, and it recently ended, and so now it's available for pre-order on Indiegogo.
All right, well, hey, this is just a quick lightning talk. Again, thank you, Jeff and Karen, for the kind introduction. Just a reminder, please keep questions, etc., focused on Python. But here's the story about this little deck we're going to go through with some code. Doing a lot of reading in the fall, and saw a lot of election analysis, and it was fun to read some of that, but I ran across a particular example that was a little confusing, and I thought, how can I use Python to kind of make more sense of this? So I gave a talk a year ago where someone asked, did I use Plotly? And I said, no, but I actually decided to try it out in this particular case. So this is going to be a quick chat about that story, right? So on the 20th of October, I read this story. There's a link below. And I saw this graphic, and it was really all about, how mail-in voting deadlines and the rules around them were very confusing. And this was published by the AP, and they had this helpful graphic that kind of laid out the rules on a state-by-state basis. And they provided, some organization around when ballots had to be received and a color coding of the rules. But frankly, I left this graphic confused because I really couldn't make sense of it. Later in the day, they updated the same article with a new version of the graphic where they kind of helpfully sorted it by colors. But really, I found I was more interested in really, how are these kind of questions segmented? Are there any other relationships that might be important, like relationships to the electoral votes for each state? At the time, I was looking a lot at this site, 270 to Win, that had this handy simulator, and you could look at which states may go which way. And I thought it'd be very interesting to kind of think about how these ballot laws relate to the potential impacts on the election, right? So I went and grabbed some data from these different locations and did some analysis and got to play with some pretty cool library called Plotly that has, as it turns out, a very useful API for doing a diagram called Sankey Diagrams that we'll talk about. And this is just one fun way to visualize stuff. So again, I started with this graphic, and this graphic really just showed the layout of states and their rules. And I took just a couple minutes because I couldn't find this electronically and put it all in this handy CSV that kind of encoded the rules for each state and the color coding, so I could just quickly get a view for what happened. And then I figured, hey, I want to look at this in a certain way, and I looked at a few kinds of visualizations, and I thought, one visualization that might be interesting would be a Sankey diagram, which is usually used to look at transfers or flows of data or content through a system. Sometimes it's energy, etc. And I thought maybe it's possible to use this diagram to look at how the ballot laws and all that stuff flow through the US electoral system and really look at the relationship of those things. You may remember this diagram from my talk last year. This is actually a precursor to the Sankey diagram that shows the influx of Napoleon soldiers into Russia and the outflux after the Russian winter, right? So to create a Sankey diagram, you really need a couple of things. And to be clear, I did use Plotly for this experiment, but there's several other great libraries out there that have some stuff that let you do similar things. And basically, to make these work, these libraries need to have a dictionary that describe all of the nodes and the links for the diagram that you want to create. And so when you're coming into a situation where you have a bunch of data, you got to look at it and say, look, what data is going to be a node and what data is going to be a link. And what I did was I looked at this and I said, hey, the categorical values of the content that I'm looking at, really those are going to be the nodes, and the sum of the electoral votes for each of the states that roll up to those categories would be the links and help break out the nodes further. So I needed to find a way to build some code that would let me kind of do that in a diagram. And I have to thank this particular developer, Ken Locke, who published this article you can see here. He wrote this function. And again, let's just remember, it's October 26th. You know, I'm not doing this as a side project. I'm doing this like as I'm reading the article at the end of the day. I had a few minutes, right? So I snagged this code from his Medium article. And basically what this allows you to do is get a data frame that contains categorical information and some value information. Give this function, the data frame, a list of the category columns that you want to be explored in the Sankey diagram, the value columns, which column has the numbers you want it to sum, in case you have more than one column with data that you could potentially analyze, and then a title. And what this does is it lets you basically pass that stuff in, and I'm not going to read all this code here for you, but basically it passes it in and it creates this temporary data frame that creates the source and the target pairs, these kind of row by row listings for everything in that data frame, and then it puts it together in this handy dictionary. And that dictionary is what Plotly needs to consume to make these wonderful Sankey diagrams, okay? I did do a couple of other modifications as I fiddled around with this in prep for this talk. I decided to do some sorting, so I added some stuff like this really to make the automatically generated diagrams look a little bit nicer, and I did pass that data frame out at the end just so I could kind of look at it as I was working on it, right? And so how this is invoked is very simple, just calling the function and getting these two outputs, and I can pass in all of the columns that I want, and I'm skipping over a number of cells because this is a lightning talk, but when you look at the GitHub repo, you'll see there's, you know, half a dozen columns or so that have the different dimensions of this data that I was looking at. So I wanted to look at what were the laws around receiving ballots, what were the laws around when states could begin counting ballots, and the state. And the values that I was really interested in looking at would be related to the electoral college's votes associated with that state. And so, gotta remember that's editable. So when I run this and look at the data frame, what the function produces is a table that looks like this. So this is basically giving me a list of rows that give the categories, the state, and then which nodes that they are assigned to. And what the Sankey library will do is aggregate all that into a visualization, okay? And I am able to do a couple of cool things because I have this function. The first thing I can do is I can generate different figures with different groups of categories that I'm looking at, right? And then secondly, I can turn them off and on very easily by just kind of hiding one of these. Now, the next thing we'll see is a page-by-page view of what the Sankey API produces from Plotly. It produces this diagram. This is the first figure where it looks at, you know, inputs where you can receive the ballots. These are for mail-in and absentee ballots by election day, and you can see how those inputs are broken out into some of those categories over here when the counting begins. And so this is just part of how I was exploring the data, and it directly relates to which states follow that particular combination of rules. So I found that was kind of interesting, right? Because I could quickly see from this, exactly which states had the ability to receive ballots by election day and count before election day closed, right? And then other states have different rules. And you can see that some of these flows cross over each other. But I was really excited to see that this kind of quick and dirty analysis could give me this kind of insight very quickly from the first diagram. So just a couple of selections of columns really helped kind of organize this in a more intuitive way. It also let me kind of play around with it by moving the graphic around and exploring kind of things that were interesting. I then went and looked at some other figures, right? So I did this figure. What happens if you start with the states? Which states have them all received by election day? And how do those relate to, again, other categories like when the counting begins? This is kind of part of the exploratory process that I went through. And again, quick and dirty. This is kind of like late in the day on whatever day of the week the 26th of October was in 2020. The third diagram, I kind of did a larger list of columns and started to look at things that I pulled from some of those other data sources. When do states begin counting ballots? When do which states allow you to receive it after election day? And then how were they leaning from some various forecasts in the electoral forecasts? And so, you can look at how these things flow through. And, it was kind of neat to look at how I could kind of plug different orders of columns in and tweak some of the kind of rules in the function around, how things were being highlighted in these graphics. And then just very quickly get this out and see if it was worth looking at further. So I was excited by that. What did I learn through this process? I learned it was actually easier than I thought it was going to be to use Sankey diagrams to look at large data sets and to do this in Plotly. Haven't had time to tweak this in great detail, but the library and the other libraries that allow you to do these things, they're very flexible, so you can make quite detailed graphics. Again, everything that we've just witnessed was essentially automatically generated by that function that I borrowed from Ken Loke. And then secondly, the Plotly library. Getting the source data to do this stuff was actually super easy. And, with a little bit of tweaking, a little bit of engineering on the data, such as changing values to make them sort in the right order, really improves the kind of initial quality of that automated visualization. I'm sure if I were to spend a lot more time kind of designing a custom graphic and really putting more time into the analysis, it could have been better. The automatic styling didn't look that great. And, you can spend a lot of time doing development on those dictionaries that the Sankey API consumes to get very precisely engineered diagrams that are, exactly what you need. But for this exercise, it was all about how can I use Python to consume all this stuff quickly, get some visualizations and play with it. And it was a pretty fun exercise, and I started to learn a little bit more about Plotly, which I thought was a cool library. So that's all I have for this lightning talk. This repo is public. I think Jeff and Karen are going to distribute it in the meeting notes. I encourage you, if you're interested, to kind of check it out and fiddle with it more. It was a fun exercise. So that's all I have to share for now. I might ask, are there any questions that that we should look at? Let me just check the Q&A here.
So there's a question from Marcos, and thanks a lot for the talk.
Oh, that's great, Marcos. Thank you so much for that. So Marcos is asking, what does the width of the flows mean, right? So that's a good question. So in this context, the value column that I chose related to the number of electoral votes for each state, right? So the kind of way to read that is moving backwards, California adds up to this one, this particular node that counts how much, which states have how many counting. I'm sorry, let me just repivot here. I'll start over. This node is showing you the states that allow counting to begin on election day before close. And the width of this node is counting up all of the electoral votes for the states that add up into that, okay? Conversely, this node, the received by election day, is adding up to 221. That counts all of these dark gray bands that you can see here as I highlight this, these four here, and that in turn is a sum of the electoral votes that are flowing through this node that have this same rule, right? So it's kind of following the tree through. That's a great question. I wish I'd mentioned that when I was going through the first time. Super. Any other questions out there about Sankey diagrams or Plotly?
I think that was an outstanding talk. I don't see any. Oh, there's a question that just came in, but I'll just finish saying that was really compelling. Great job. There's a question from Frank Lemon.
Okay, Frank. Let me just read this. Thank you. Where did you learn about Sankey diagrams? I'm guessing Tufte discussed them. Tufte definitely discussed them. I'm a huge fan of Edwin Tufte and his kind of pioneering work on the design of visualizations, not necessarily Python or anything, but more just kind of the academic work. For those of you who don't know, Tufte was a professor at Yale who did a lot of kind of pioneering scholarly work around information design and visualizations in particular. And so I guess your question of where did I learn about Sankey diagrams? It's somewhere in the mix. A lot of people have done them, but Tufte definitely talks about them in his materials, and there's others that cover them. One of the original graphics that I mentioned very early in the talk was this graphic, which was done by a French civil engineer called Charles Menard in the 19th century. And this wasn't called a Sankey diagram at the time, but it was pioneering the same idea, where the width of this graph is showing the number of soldiers and the distance on this graph is showing particular locations in Russia when Napoleon was marching to Moscow. Later on, Mr. Sankey, I'm sorry, I can't remember his first name, kind of formalized the thinking around this and started applying it to systems, engineering systems, where there were flows of information or flows of energy and things like that. I think somewhere here is a link on Wikipedia, which I would go and look at, and there, here it is, and this gives you kind of the history of Sankey and the flow diagrams. But they're surprisingly useful for different things, and I'm excited by the diagram in itself, and also excited by the fact that the visualizations are interactive from the beginning, right? So I can interact with them by going back to the function and changing which columns I'm looking at, and I can interact with them by looking at different orders of the information here. So as an example, I'll probably just start with this one. With this one, sometimes the Sankey diagram is going to produce things in a certain order, and I may decide, hey, it makes more sense for me to kind of literally drag these things around. So this is something where, hey, if I can move some of this stuff out of the way, patterns that may not be obvious when it's produced automatically kind of make a lot more sense, right? And I can, kind of play with them in that way. And you can do neat things with mouse overs that provide additional tooltip insights that you can also customize depending on kind of what data is available. So it's pretty cool what you can do. Again, this is just sort of the quick and dirty, what could be generated quickly automatically. Good question.
Okay, great. Hey everyone, this is Wesley Chun. I'm a developer advocate at Google, and that's my Twitter if you're interested in following. For some reason, I've made more political tweets over the last 5 years than I have in my entire life, so hopefully that will trickle down and get back to pure tech again. So apologies for dealing with me for the last 4 or 5 years. So today I'm going to talk to you about serverless computing, focus on Google Cloud, but a lot of these concepts will apply to other cloud vendors that have serverless computing as well. And then kind of like, showing some code samples in Python. Save up your questions, type them into the Q&A, and Jeff will collate them for me. If after the event is over and you have further questions, feel free to either grab the barcode or the short link here. That's an open Google Doc that I actually take questions from the public, and I will periodically check and answer questions. Really, it's for questions that you want others to see as well too, because maybe you think other people may have the same question as you. So anyway, so that's just another resource for yourselves. My goal at work is to enable developers everywhere to be successful using Google Cloud and other Google developer tools and APIs. My focus areas are on our serverless tools. Obviously, that's why I'm doing the talk tonight, but I also focus on higher education, Workspace, which used to be called G Suite, which used to be called Google Apps, which is basically Gmail, Drive, Calendar, Docsheet, Slides. The apps themselves don't change. The name is the collection of them. I also know a little something about our AI ML APIs, and what I'm more interested in at work, which is a little bit challenging, is making multiple Google products play well together so that developers get a more seamless experience. And part of my job involves me speaking to developers around the world when we used to be able to travel. I guess now I can just do it over Zoom. I also make videos, so you may see me online. I write code samples. I make code labs, which are hands-on tutorials. And then I also write blog posts. So my development background is I've been an engineer for several decades. I was one of the original engineers that built Yahoo Mail many years ago. I teach outside of work at, every couple of years, I do a Python class at Foothill College here in Silicon Valley, and then I am a member of the Python community. All right, enough about me. This talk is about you. So first I'm gonna provide sort of like a high-level overview of cloud computing. I find this to be absolutely essential, and the main reason for that is when you say the term cloud computing, everybody has sort of like a different take on it. And so the purpose of this is just to normalize the vocabulary so that everybody knows what we're talking about. And then we'll kind of like introduce you to like, how does Google Cloud fit into this? Where do the products sit? And then, focus most of the entire rest of the talk on our serverless platforms. And then perhaps show you a couple of inspirational ideas of what some folks, either my colleagues or myself, have built with our serverless tools, and then we will wrap up, and I'll give you lots of links that you can chase them down, including links to the slide deck and other resources. All right, so here's our, in fact, I tried to make this cloud computing overview to be very, very vendor agnostic, so not focused on Google whatsoever here. So big question is, what is cloud computing? It means lots of different things to different people, so that's why we want to normalize that vocabulary. The main word that I like to associate with cloud computing is outsourcing. You're outsourcing hardware, big disk, and even applications. And the most famous one, which of course I worked on, is email. So many years ago, in order to send and receive email, I mean, it sounds really basic, right? We used to have a workstation, and we used to have to have, running SMTP, IMAP, or whatnot on our desktops in order to be able to receive email. As the internet became more prolific, probably it's not a good idea to ask grandma to be managing SMTP on port 25 in order for her to be able to send and receive email, right? So what we've decided to do then as a collective society is to outsource our email to an email vendor that can actually take care of all that for us, so that all we need to do is log in, check our email, send our replies, and then be done with it. So that's you've outsourced your cloud vendor, your email vendor to the cloud. So that's one example. And that is part of sort of like a larger view of what cloud computing is. Email sits up at the top level. So that is called software as a service, where you're outsourcing applications, and email is one of them. Notice that when you are using a SaaS app, and the way you tell, by the way, that you're using a SaaS app is if you're logging in somewhere with a web browser, or you're logging in through your mobile app, that is very likely a SaaS app, okay? And related to that, notice that you don't really care what language that tool was written in. You don't care what operating system it's on. Is it on Windows? Is it on Linux? None of that matters. Same thing goes for how many VMs is running this system. You don't think about it and you don't care. So that is the purpose of software as a service, is you're outsourcing apps. Down at the very bottom is infrastructure as a service. So this is the raw hardware that you are outsourcing. I don't want to buy a computer. I don't want to buy a big disk. I want to rent it from a large vendor like Amazon or Microsoft or Google. So all the VMs are here, the big disks are here, so that's infrastructure. Now, the reason why I point this out is because I'm logically going to make my way towards the middle. And how do I do that? Well, the way I do that is I ask you the question, hey, if your purpose is to run applications on this hardware that you're renting, guess what? You can't just start up a VM on AWS or in Google Cloud and just expect to just plop your app in there. You have to decide what the operating system is. Do I do Windows Server? Maybe I don't. Maybe I do Linux. If so, I have to choose which distribution and then which kernel version. And then on top of that, once that decision has been made, you have to pick a database server, a web server, and all these other things. And then until finally, you can actually throw your application code and run it. Okay, so it's a little bit of work. So if you're just getting hardware, it requires a little effort before you can actually run that application. So that's why there's a sweet spot in the middle, which is platform as a service. So this comes in lots of different form factors, and we're going to spend most of our time here tonight. But with a system like App Engine, you basically upload your application and then Google runs it for you. If you upload, something to Lambda, then Amazon runs the function for you. Same thing goes for an app on Heroku, Salesforce run it for you. So you're basically outsourcing the platform. Now, the cool thing about the middle is you only have to worry about your code, and that's what we do as developers, right? I don't really want to think about VMs. I don't want to think about operating systems or database servers, load balancers, software upgrades and things like that. That's for our DevOps team to worry about, right? So that's why this is a nice spot, because you just worry about your code, and all of those things I was telling you about that you had to worry about if you just did infrastructure are no longer a worry for you, because the PaaS system takes care of that for you. All right, so those are like the three major cloud pillars. So outsourcing applications, outsourcing hardware, and finally outsourcing your logic hosting. Of course, like any other large-scale system, there's going to be gray areas in between. So, cloud is no exception. So somewhere in between infrastructure and PaaS, you have systems which are more than raw hardware, but they're not exactly a system that can take application code and just run it for you, right? So you see that most of these things are going to be like data services. Like you're going to see databases, data processing, data analytics, machine learning. You even have like containers and things like that. So yeah, and networking services as well too. So again, not quite hardware, it's more than hardware, but not enough to actually run application code, unless your code is just like a chunk of SQL or something like that. But that's not really an application either, right? All right, and the last one is between SaaS and PaaS, you have what I call, again, and this is kind of just my opinion, there's really no name for this level, but I call these things restricted PaaS systems. And the reason why I call them that is because they're very, very close to the SaaS layer. In other words, if you're using a PaaS system like Force.com or AppScript, you're actually relying on its use of data that live at the SaaS level. So when you're using AppScript, you probably should have some workspace data up here. If you're using Force.com, you probably should have some Salesforce data, because if you don't, there really is no reason why you would want to use these more restricted PaaS platforms, and you should really opt for the more pure ones because they give you more flexibility in terms of what they can do. They're not, domain specific like these PaaS systems are. Okay, so that's really the basic, 5 or 3-tier system with some gray areas in between. And then sort of to wrap it up, let's take a look at the whole thing, but turn it sideways and look at that from the perspective of what are you responsible for? If you've outsourced your email application, guess what? You've outsourced everything to your cloud vendor. I mean, except for like, your personal email settings, right? Everything else is up to the cloud vendor, right? Think of Gmail or Yahoo Mail. Yahoo and Google have to take care of the app, the data, the runtime, and everything towards the bottom of the stack. You don't think about anything. If you use a PaaS system like I described, you write your code, you upload it to App Engine or Heroku. You're responsible for your application code as well as the data for that application, but everything else is handled by the cloud vendor. If you choose infrastructure as a service, you've outsourced all the raw hardware and virtualization, but guess what? You're responsible from the operating system layer on up. And then if you're not using the cloud, you're on premise, then you are responsible for everything, okay? So that's really sort of like the high level overview of cloud computing. So let's dive into Google Cloud. So Google Cloud is a large vendor. We produce two very well-known platforms. One is the Cloud Platform, and the other is Workspace, G Suite, Google Apps. A lot of times people think that the left side is for developers and the right side is for users. Not quite 100% true. And that's because the right side, you know, behind Gmail, Drive, Calendar, Docsheet, Slides, there's also an API, so you can code them as well. All right, so let's kind of like talk about where does Cloud Platform and Workspace fit into our little cloud diagram that we discussed. The main idea is if it is anything near SaaS flavored, anything SaaS flavored is going to belong to Workspace, and then anything that is sort of kind of away from software as a service, anything from PaaS level on down, that is GCP. Okay, so the line is pretty clear. So that's pretty easy. All right. We have a lot, you know, Google Cloud provides a lot of different places that can, you know, do compute for you. All right. So we have VMs all the way to the left. We have slightly more than VMs, you know, managed VMs. That's like Kubernetes, GKE, and then Cloud Run. There's App Engine. There's Cloud Functions. I'm only going to focus on the what we call fully managed services, which are things that you don't have to think about anything. We manage everything for you. You don't think about instances, right? We basically determine, you know, our systems determine how many instances of your app should be running based on the traffic that you're getting and things like that. So it's really like a armchair application deployment where you don't think about things. You know, you can give talks on all the other, you know, we can give talks on any of the other products as well too, but I want the laziest, I want the laziest audience. So I hope you all fit into that category because I'm pretty lazy myself. You can tell because like my alias file for my shell is like 12 pages long or something like that. I really don't know Linux or Unix. I just know like these 1 or 2 letter commands because I am just that lazy. Anyway, if you want to take a look at this chart, the link to it is down at the bottom. All right, so let's dive into serverless. So, well, we do have VMs. We do have big disks. You can get, you know, for VMs, you could get anywhere from an F1 micro, which is actually free. For all of you who are GCP customers, everybody gets one VM for free every month. You know, I think it only has like 4 gigs of RAM, 2 gigahertz CPU. You know, it's not a huge machine, but it is free every month, right? All the way up to a monster that has 416 vCPUs, almost 12 terabytes of RAM, and 256 terabytes of disk. And you can choose what kind of disk you want. So that we do have VMs for you. We also have big disk like cloud storage. So that's like S3, if you're familiar with that. That's your data lake for all of your amorphous blob data, because you all know that all of your data rivers flow into your data lake, right? So we do have big disk and we do have giant VMs and all that stuff, but why would you want to use them? Okay. And by the way, if you see, there's a list down there that shows we support most major, you know, server operating systems that are out there. Okay. So again, the question is why? Because I already mentioned that if you're going to run an application, you have to think about all those extra things. And so we want to sort of like take that away from you. And that's why you should consider serverless. And that's one reason. There's other reasons as well too. So obviously serverless is a lie. Of course there are servers, right? It just means you don't have to think about them, and that, you know, in exchange, you get to focus on the solutions you're building for your, you know, your organization as well as your customers. Okay. Why would you consider serverless? According to analyst research, and once you get the slides, you can click on the links down in the lower corner there. They have sort of seen that corporate spend globally on serverless is doubling every other year, and it's currently projected, you know, pandemic aside, it's projected to continue at that rate over the next couple of years. So we'll see at the end of this year whether it is near 8 billion or if it took a little bit of a back seat. And then one of the cool aspects of serverless is, you know how like when you're building a solution, your boss tells you do the 80-20, right? solve 80% of all the use cases, and don't even think about the edge cases because, you know, we want to get first to market, right? So the interesting thing is that serverless also takes care of the 20%. It's kind of weird. So let's say your app goes crazy, you know, it goes viral. Well, then some of our serverless platforms have auto scaling. They will be your new best friend, because if you as a startup did not invest enough in hardware and your service goes crazy and you only bought enough or rented enough servers to get you to like 100 million users, but not 500 million or a billion users, then you're not going to be doing good, right? Because at some point when your service gets really popular, your new customers can't get to your app, so they don't know what the hell's going on. Your existing customers are going to be upset because they can't get to it either, and that's going to lead you down the wrong path. And then similarly, let's say you spent too much money on hardware and not enough on engineers to build that awesome solution that you were planning. In that case, you're not getting much traffic. You've got a lot of machines humming in the data center. They're not really doing anything. And you're running out of money, and you're also not going to end up in a good place for almost a similar reason. So the cool thing about serverless there is that we scale down to 0, which means that if your app is not getting any traffic, it is not running on any instance, which means you're not incurring billing, which means you're not paying. So that is one of the best things about serverless, is the ability to scale to 0. Or to go crazy, like when we hosted the royal wedding in 2011, that was an App Engine app. Traffic was like this, and then the wedding started. It went to like, 50 requests a second, and then 100, then 300, then 500, then 1,000, then 3,000, then 5,000, then 8,000 requests per second. And nobody went down, nothing went down. Our SRE people didn't get paged that something was melting. It just recognizes the traffic that's incoming, and it spins up enough instances to handle that traffic in whatever region your apps are running in. So that's the cool thing about serverless, is that it handles the 20 as well as the 80. So where does serverless again fit into our overall diagram? Mostly it is anything PaaS flavored. But I do want all of you to recognize that if I am talking about, Kinesis or RDS or Cloud SQL, those are databases, and it is true that it's serverless because you've outsourced your SQL service, and it's spinning up servers on your behalf, and you don't have to think about it. That is true that they are also serverless. But what I'm focused on mostly is serverless compute. So it's really just these things in the middle, even though, there are lots of other serverless types of products, okay? So that's why these are kind of like light orange, not the full orange. So I'm going to mostly talk about these 3 products the most. But keep in mind that this also counts as serverless. It's just not serverless compute. So anything that's kind of PaaS flavored is what we're looking for here. Okay, so the first one is App Engine, and this is app hosting in the cloud, and this is Google's first cloud product. It launched in 2008, and in the mid 2000s. Well, why did this product come to being our first cloud product? So the original team went out and asked developers, the .com days are here. What are the biggest challenges to launching a global, worldwide service that can scale? And they came back with all these little brown boxes, like, oh, we have to worry about the operating system and upgrades. We have to worry about logging, monitoring, the database, the web servers, all these things, by the way, which all apps need to worry about, right? It's not just that one particular app that they have. So the product team took this under consideration and also built in auto scaling, which is not a box that you can see here, but auto scaling is probably the most difficult thing to build, right? I want to only pay if people are using my app. I also want to be able to code these in the most popular development languages today. So all of those things became requirements. And in 2008, in April, we finally launched App Engine, taking all those little brown boxes, throwing them into one giant, large brown box called App Engine, making it available first in Python, followed by Java, and then Go, and then PHP, and then much more recently, Node and Ruby. But you got to look at some code. So here's your, the world's smallest web app in Flask. So you need at least 3 files to have a web app. And so here we have the config file, which is your app.yaml. It says what version of Python you're running. You have your application code. And so if you go to your website at the main, the main directory, which is / it returns hello world. And then you have some, packages requirements .txt file. Once you have your app, you download the Google Cloud SDK. That installs a command line tool called gcloud. And then you just run gcloud app deploy, and typically in less than 60 seconds, your app will be available around the world. You get a free URL, whatever your project ID is, .appspot.com. Obviously, if you use this, professionally, for your company, you can obviously map, DNS map a custom domain to it. That's not an issue. So if you want to play around with this, there's a link to the quick start, which is pretty much that code. Maybe it's been modernized because I know Flask is like on version 1.1.2 at least now. So it's not, I don't have the latest on the slides, but it's pretty easy to do. Once you hit gcloud app deploy, it does take, it does ask you some questions like which region you want to run it and all that kind of stuff. And then once you answer all the questions, then you'll see the deploy go on. Again, it's typically under a minute. Sometimes if it's really busy, it may take slightly more than a minute, but it doesn't really take a lot of time to get your app up and going. So that's pretty cool. All right, so that is App Engine. And if we have time at the very end, I'm happy to kind of like demonstrate how this works, but it's pretty basic. Some of you who may have been using App Engine since the early days may have recalled that there were a couple of other commands. So the older commands were called appconfig.py or dev app server. So those have been deprecated in favor of gcloud. Gcloud is like the one command that you can use to talk to any cloud product that we have in GCP land, whereas the 2 older ones were only available for App Engine. So it is kind of limiting in that you can't access other cloud tools using those commands. So that's why we created gcloud to kind of like give you access to all the other GCP tools. Okay, so App Engine is pretty popular with anything that's kind of like social or mobile backends, social apps, mobile apps. Mostly consumer apps that have unpredictable traffic, whether you need to scale to 10 billion or down to 0. If you ever heard of Snapchat, a very popular a photo sharing service with the young kids today, that's all using App Engine as well. Besides App Engine, they're using other cloud tools too, but a lot of their stuff is App Engine. We have a pretty good free tier, so it's pretty good tool for students to use if they're doing apps at school. It's also good for small businesses, mom and pop shops that they don't go viral. If you don't go above the free tier, you're not paying anything, right? And then it's also good for internal business apps as well. So lots of different use cases. So I want to talk a little bit about modernizing. So this part of the App Engine talk is focused on people who have been using App Engine for the last 12 years. So the original runtimes lasted about 9 years or so, and they were, Python 2, Java 6, 7, 8, Go 1.6 to 1.11, PHP 5. So these language versions have all been deprecated by their respective communities at those dates. And however, Google Cloud is committed to keeping these running long term. So if you are stuck on those platforms, we don't want to shut you down, even though your community has determined that your language version is obsolete. That's cool. The second generation App Engine service came about a couple of years ago. So we're supporting all the, the more modern versions of everything, right? So Python 3.7, 3.8, 3.9, Java 11, Go 1.12 and newer, PHP 7. So migrating to the next generation has a lot of benefits. Okay, it's faster, it's sleeker, deployment is quicker. Well, actually, this is on the next slide, so I don't want to take away too much thunder from the next slide. There is one big challenge, and that is the original runtimes had a lot of built-in services, built-in database, built-in memcache, built-in search API, built-in images API, built-in task queues and things like that. None of those things are built in anymore in the second generation, and I'll go over why that is the case either on this slide and the next slide as well too. So the next generation gives you some improved capabilities. It removed a bunch of limitations, but more importantly, you're getting access to the modern versions of the languages. So, right, everybody's coding in Python 3 these days. So there should be no reason why we should hold you back. Also, in old Python 2 version, the old legacy app engine, do you remember, for those of you who used the system, do you know how, you couldn't use certain Python packages, or it had to be pure Python code? You couldn't, it was harder to work with Django and things like that. So one of the things that we did was to remove a lot of those restrictions so that you're developing with the normal version of the language that you're used to, not sort of like a customized restricted version. And then this also gave us the ability to support new languages like Node, Ruby, and perhaps a few other ones that are coming down the line. Another restriction is that back in the old Python 2 days, you used to have to do pip install of those third-party libraries that you wanted to use, like Flask and whatnot. You'd have to bundle that into the same application folder as your app code, and then upload everything. And of course, that restricted you because, Flask or Django or Pyramid, if you're downloading an entire web framework and then uploading it to App Engine, all those things count against the total number of files you can upload, as well as the size of the files that you can upload. So there was that restriction. Nowadays, you only need to have requirements.txt. You no longer need to bundle your stuff so that you don't take a hit for the size and the number of files in those third-party libraries. Now, the challenge, no more built-in services. So all these original built-in services, either they've matured enough to become their own Google Cloud products, like Cloud Data Store, Cloud Memory Store, Cloud Task, Cloud Scheduler, or there really is not quite a good replacement. So for example, for email sending, there are a lot of email senders out there, so we recommend that you move off of the App Engine email API, which was very restrictive anyway, because we don't want people writing apps that just spam people, right? So you should be using a professional email sender. We don't have a search API anymore. I know for some strange reason, people think Google's a search company. Why don't we have a search API? Haha, very funny, right? The same thing goes for images API and users API. So instead of like the users API, you would probably use something like Firebase Auth or something like that, which lets people log in from federated login basically. Images API, there are some recommended Python libraries that you can use as well too. So not everything has a direct replacement, just sort of like the main core type stuff. And the end result is that if you're not using proprietary APIs and libraries, guess what? It will make it easier for you to port your apps elsewhere. So of course, we want you to stay on App Engine and stay within Google Cloud's family of products. But if you're really upset and you really wanted to move to Amazon or Microsoft or whatever, it makes it easier if you're using standard libraries that other apps are using already, right? So we want to, we're trying to be the anti-vendor lock-in company. We really want to make it developer choice. Right? So if we can keep you happy on GCP, that's great, whether you choose to modernize your apps, which I'll talk about in just a moment, or if you have a huge App Engine app and you'd rather break that up into multiple microservices and run that on Cloud Functions, or if you want to containerize your app and run it on Cloud Run, or if you want to just use VMs either with Kubernetes or just raw VMs with Compute Engine, that's fine too. All right, so there's lots of different options for you. So what are the things that are changing? So whenever you see, the libraries that are listed in the first generation as to what is built in and what's available, we show you here in the second column, like what are your recommended, what are the recommended alternatives for you to go to. And you can see how there used to be restrictions on libraries, but it's not restricted anymore. You have more modern language versions. Same thing goes for outbound network access. That's now unrestricted. So we're trying to make things better. We're trying to make things more portable. We're trying to make things looser so that you can kind of like go, best of breed. You choose the best library that's out there instead of being forced to using what Google gives you, right? So all those things are pretty positive, and you can see kind of like a version of this chart at the link down below. Okay, so what doesn't change? Of course, the ability to handle traffic and spin up instances for you. The auto scaling doesn't change. If you learn the gcloud command, that doesn't change. You have the same type of service guarantees for any of the services that have become generally available. The free tier doesn't change. Every app gets 28 hours free per day. And then you get 1 gig of network traffic as well as data storage. Again, now that you don't have to upload your third-party packages, that 1 gig becomes pretty valuable. So you can have a lot more files and data files as part of your application. So how do you migrate and modernize? One is you just lift everything up. You switch to, away from the proprietary libraries to either the replacement, either from us or from a third-party vendor. You break up a large app into multiple microservices, or kind of like APIs with Cloud Functions, or you containerize it. Containerize your app for Cloud Run. Either you can use Docker, or if you want to avoid Docker, you can use build packs. So I'll talk about that later on in this talk. Okay, so let me just give you an example. So the original App Engine came with a web framework called Web App 2. Typically, people only use this with App Engine. It is, you can use it outside of App Engine, but its main strengths are to be able to give you access to those built-in libraries. And so we suggest that you you have to port away, because Web App 2 is not supported in the next generation, at least not at this time. You really should move to a web framework that is more modern, that supports routing. So Flask is one, Django's another. I think Pyramid does as well. Web.py, I think, does too. So as long as the web framework you move to supports routing, then you're good to go, okay? Because in the old Web App 2, everything was object-oriented, so your handlers were object-oriented, and so for every HTTP method that your app handles, then you would need a Python method of the same type. So for example, this handler handles HTTP gets, so there's a method called get. And then down below is a list of all the different routes to all the different handlers that you have. And then you also have an equivalent inside app.yaml as well. But with Flask, as some of you who already use Flask know, it's not object-oriented like Web App 2. You just write functions, and then you just decorate the function with whatever path. And so whatever path that comes in, it gets routed to whichever function is the handler. So if you modernize from Web App 2 to Flask, you're actually simplifying your code a bit. All right, another example is to talk to data store in old App Engine, you use the NDB library. So you can see it on line 16. You would import the NDB library from the App Engine, modules that came bundled with App Engine, and then you would create a visit entity. You have to declare a data model class with properties. So a visitor property is a string. A timestamp property is a date, basically a timestamp. And then, so this is a simple website that just registers every visit to / basically. So anytime somebody comes in, you store the visit. So I'm just going to store their URL, the IP address that they came in from, as well as what browser they use. So I'm just saving that in the visit object. Here are the parameters, and then I just put that object straight into the data store. And then below, after that's done, it will call fetch visits to show the 10 most recent visits to the web page. So this is just a query that looks for the 10 most recent visits and just sort it in reverse order, reverse chronologically based on timestamp of visit. So just display that using the index file. So it's pretty plain and boring. Porting this to Cloud NDB. Okay, so Cloud NDB is now the Google Cloud version of it. So it's matured into its own product. This one's an easy port, because the only thing that Cloud NDB, how it differs from the original App Engine library, is that you need to use the context manager. So all you do is take your existing data store code and just stuff it into a with statement, and then you're done. So you can see that this is identical to what's in the with block here. So that's an easy port. A little bit more challenging, which I don't have time to cover, is our other services. Yeah, question?
Yeah, is this a good time for a couple questions? Or?
Yeah, I was going to say, if anybody has any quick questions about App Engine, I'm willing to entertain them now before we move to Cloud Functions.
Great. So we have one right now. So from Hassan was asking, was Web App 2 based on WebPy?
I don't believe so, but I'm not 100% sure. WebPy has a lot of magic, and I don't see that kind of magic in Web App 2. Okay. And by magic, I mean monkey patching, so you don't know where things come from.
Oh. So are there any other questions at this point with what he's covered so far? I just want to say your explanation of the PaaS and all that stuff and where the different services fit in was the best I've seen, I think.
Oh my God.
Most of the time you go to, like, I won't say any other vendor names, you go to their website though, trying to figure out what their products are. And it's like digging to figure out what they have weird names and what they actually do. So it was really helpful for me, at least, to see.
No, that's great. I'm also, you know, it's also possible that our website isn't that clear either. It's just that, you know, because I teach outside of work, I have to sort of be able to frame things in a way that people can kind of absorb as quickly as possible. So that's kind of like my main goal. So yeah, I mean, I'm not gonna, you know, our docs are really good, I have to say, and I've heard a lot of great comments about it from customers. But you know, everything can always be improved, right? That's very cute. Somebody said Fortran in the chat. So if you remember, 1 year, that was our April Fools that we launched App Engine for Fortran. It really wasn't real, but it would have been hilarious. However, of curiosity, if you're interested in kind of like older languages, one of my colleagues did write a blog post because he got Pascal running on a Cloud Run container. So just look up Google Cloud, Pascal, Cloud Run, and you can take a look at that. So, all right, cool. Let's move on to Cloud Functions, which is function hosting in the cloud. So why does this product exist? Well, maybe you don't have an entire app. Maybe you don't want to worry about these stacks, right? Like a LAMP stack or a mean stack. I'm sure everybody knows that LAMP stack is like Linux, Apache, MySQL, and PHP, and mean stack is like Mongo, Express, Angular, and Node. So there's all of these stacks, and you have to you have to learn something really big in order to put something in the cloud. And the main idea behind Cloud Functions is that maybe you don't need to learn all that kind of stuff. Maybe you just have small little functions that do little utility things. And you just want to go fetch the weather. I want to go and, you know, check a sports score. I don't want to write an entire app. Or maybe I want to string together a bunch of these little tiny APIs and make an app out of it. That's called the Jam stack, which is the newest kind of stack, which is JavaScript, APIs, and what I forgot what M was.
Markdown.
Yeah, Markdown. That's it. Thanks. Yeah, so just like a really loosely coupled type of app that's made up of APIs and simple Markdown pages and things like that. So anyway, so that's the latest stack in case you're curious. One of the cool things, and you'll see them bolded on this page, that App Engine does not have is, like App Engine, you can call a Cloud Function just by, you know, using a browser or using curl, and you're just hitting it with HTTP. But one really cool thing that Cloud Functions does that App Engine cannot do yet, is be able to run based on a background event, like, oh, a message was received on a pub sub queue. Oh, somebody dropped in a file in cloud storage. Oh, somebody logged into Firebase using your mobile app. So you can actually trigger a Cloud Function based on background events, which is really cool. So I'll show you a demo, well, not a demo, but a demo app. I'll talk about the app and let you take a look. Like App Engine, it's also auto-scaling and highly available, and it's also pay-per-use. So in other words, if nobody's calling your code, you don't have to pay. So that's that. There's also a more flexible development environment. You can code in a terminal and command line like App Engine, but in addition, Cloud Functions allows you to go to the Cloud Console, so console.cloud.google.com, and you can create your function, you pick your language, you code it, you deploy it, and you can even test it, all from the dev console. So you don't even need a command line. But if you like developing locally, we also have something called the functions framework, where you can actually test your functions locally. You know, it spawns, you know, Python's local web server, it executes it and does that kind of stuff. And then what the functions framework will do is it'll bundle everything together into a container and then run it on Cloud Run. But it is produced by the Cloud Functions team because we want to give you even more flexibility if you want to develop very, very locally. So that you'll get a link to that functions framework. And then also the other cool thing is functions are useful for mobile apps. And they're so useful that we created or at least the Firebase team sort of like shrink wrapped our Cloud Functions and made a Firebase version of it called Cloud Functions for Firebase, where you have a lot more connectivity to Firebase tools. So some of you may be familiar with the Firebase real-time database. A couple of years ago, Google acquired that entire company for that database. And then what we did was we added all these other mobile developer tools around it to make it an entire mobile development platform. So things like mobile crash test reporting, multiple device testing, so you don't have to buy every single Android device in the world to kind of test to see what your app looks like on it. So it simulates all that in a lab, a virtual lab for you. There's like deep linking, there's app indexing. All of these mobile development tools makes Firebase, very sort of a complete and robust scenario where you can build apps in, for iOS. You can build things for Android. You can use Flutter as well. But the main idea is they've sort of bundled some of the cloud products like Cloud Functions and Cloud Storage specifically for Firebase. And like App Engine, Cloud Function supports a whole bunch of different languages. And the ones that are italicized are in beta, but the ones that are not italicized are generally available. So let's see what your hello world looks like. One-liner. It's much simpler. No config file, no packages file. Of course, what that means is that your deploy line is a little bit longer because you basically have to specify all the config stuff on the command line. And then, just like App Engine, in less than a minute, you can curl to it if it is triggered by HTTP, or you can visit it with a web browser. You can make it trigger on those other background events like cloud storage, Firebase, and things like that. So in that case, you wouldn't be able to, but if it is triggered by HTTP, because you specify how your function can be called, then you can do that. And then this is also part of the quick start. You can click that and see this code and build it yourself and deploy yourself. It's pretty quick, much faster than App Engine, actually. All right, the last GCP serverless product is Cloud Run, which is container hosting in the cloud. So where did this come from? Well, the main idea is containers have gotten very popular as of late over the last, I would say, like 10 years or so. And the reason why is because they're very, very flexible. Most people, when they want to run apps, they have kind of like a special custom mix of what database they're using, what web server they're using, what caching server they're using. And they want to be able to deploy and develop using any language they want. They want to be able to bring in any library they want. And even binary libraries, right? Things that are already pre-compiled. And unfortunately, serverless doesn't really give you that, right? App Engine only supports N languages. Cloud Functions only supports N languages. You really can't use binaries because, in the sandbox, we're very paranoid about security and things like that. So you just didn't have that kind of flexibility with serverless. The other cool thing about containers is that, over the years, Docker has, curated a really nice ecosystem of different base images, depending the type of app that you want. And really, containers is an industry standard. But what we really want is, the flexibility of containers. But we also like serverless too, because, serverless is so convenient. It takes away from thinking about machines, and deployment is pretty easy. But it doesn't support that language that we want, or we do want to use binaries, or, I don't want to write against proprietary APIs. Why do I have to choose between the flexibility of containers and the convenience of serverless? Why can't I get the best of both worlds? And you couldn't until now with Cloud Run. So Cloud Run is basically, I would say, it's a serverless container service. Okay, so we're running containers for you in a serverless way, meaning that if your app gets traffic, your container is up and running. But if nobody's calling your app, your container is shut down and you're not paying for it. So it gets all those benefits of containers, like you can use any language, any library, any binary. The only thing we ask from you is that you need to have an HTTP port open so that our system can call, send your customers traffic to your app, and it has to be stateless. All right. So if you need to have persistent storage, call out to Cloud Firestore. Call out to Cloud SQL. Store your state somewhere that is not your app. Your app needs to be idempotent. Okay, so the way you do this is you build your app, you bundle it into a container. You can either use Docker, or it's easier to use Cloud Build. Cloud Build calls Docker, or I'll show you build packs on the next slide. But the main idea is you build your container image. It goes into the Cloud Container Registry. It checks to make sure you don't have anything bad. And then once it's in the registry, then you can deploy it to Cloud Run. And we also have a really cool GitOps feature that allows you to do CI/CD. Well, it's mostly CD, where if you just do a git commit and then push, they'll automatically trigger a cascading set of events that will rebuild your container and deploy it to Cloud Run and have it live, again, pretty quickly, and usually under a minute, just like Cloud Functions and App Engine. And you also get a custom domain with your Cloud Run app as well. Okay, so your MVP is going to look very similar to your App Engine app. Like I said, you can use any language you want. However, we do have quick starts in these 10 languages that you see here. at least these 10. There may be more. But the main idea is this is almost like the Hello World MVP for App Engine app. The only difference is that you do need to start up your web server on port 8080 because that's the one that Cloud Run is expecting traffic to come in on. And you can go and grab this code and try this quick start at the link down below. By the way, since if you're using Docker, you do need a Docker file. It takes a little while to put together a good Docker file. You should definitely have a Docker ignore. That's a good practice. And then, of course, requirements package requirements file. Then you use gcloud's build to do like a Docker build, Docker push, which is basically create your container and stick it in the registry. And then to actually run that container, then you do gcloud run deploy. That's like Docker run. You give the name of your image that's in the registry. Say you want to use the fully managed version. And again, in less than a minute, you have your app available globally at a special URL. All right, so that's great. However, there's a group of users, maybe like me, who have never used containers before. I know it sounds shocking, right? And maybe you don't want to learn about containers, or you've discovered that building a great Docker file is really hard because it's too easy to build an inefficient container image where you include too much stuff or you've got layers in the wrong order and it's just a total mess, right? So for you, we have build packs. So you can build a container without doing Docker files at all. In fact, what the build pack system does, and by the way, it is a cloud native open standard. It just so happens that Google's cloud build packs are, adhere towards that standard, and it's also used by the functions framework if you want to develop all of your cloud functions locally and then deploy to Cloud Run. So what it does is instead of needing a Docker file, it will actually go and dig into your app, look at your code, and see exactly what packages you're using. And then it builds the most optimal container possible. So it doesn't matter what language. Notice I have a Node app here. I have a Python app here. That your deploy line for Cloud Build Packs is identical because it figures out. I probably should have said my Python app instead of my Node app here. But it does, I think I just want to show that the commands could be identical. I could just say my app. How about that? Could be completely identical. It doesn't really matter because it figures out what language you're using and it builds the best container possible. So you can read about the launch blog post down below, as well as go to the GitHub page. Okay, so people ask, how do you decide which one of these three to use? Because there's a lot of options here, right? So typically, by the way, this is up for debate. I mean, I really can talk to you about it. You can talk to me, you can argue. Theoretically, you could put check marks in every single box. Just because a check mark is not there doesn't mean you can't use it for that use case, okay? I'm just thinking of what are the most common use cases or what are the recommended use cases. So for example, anything that's kind of like web app flavored, that's kind of App Engine. If you want to containerize it for Cloud Run, that's great. All of them can be touched by HTTP. Cloud Run is mostly focused on containers, and then anything kind of API mobile flavored is going to be Cloud Functions, perhaps App Engine, because App Engine has an auxiliary product called Cloud Endpoints that basically allows you to turn your app into, it automatically builds API endpoints for your app. That's why it's called Cloud Endpoints. So that's why the check marks are there. Internal apps, typically App Engine, Cloud Run. You probably wouldn't do an app on Cloud Functions unless it was a Jamstack type of app. All right, and then any kind of like long-term data processing, you probably want to have an app running it. So that's why it's App Engine, Cloud Run. And then automation, kind of like similar, Cloud Functions can be used, different Cloud Functions do different parts of a workflow, or you can have one giant app managing it. Same thing goes for event-driven stuff. Cloud Run, Cloud Functions have eventing services. App Engine does not yet, but at some point, hopefully it will. So anyway, these are just some common use cases. Let's really quickly, let's wrap up by just taking a look at some example apps. Oh wait, one more serverless platform, I'm sorry. Oh, I have to apologize ahead of time. I have to show, I know this is a Python user group meeting, but I have to do some JavaScript. I know, boo, hiss, right? There's just gonna be a little, in fact, I already showed you a little bit of JavaScript already with a .js file. So just a tiny bit of JavaScript. Maybe one day we'll be able to do Python with AppScript too, okay, hopefully. So anyway, what's AppScript? It is a workspace serverless tool. It is a customized JavaScript runtime that helps you automate things. And it also has really good integration with both Workspace as well as other Google tools and external services. So it's really easy to code because when using an API, typically you have to kind of like import the client library for the API. You have to create a networking endpoint. You have to create an API client, and then you talk to it. But with AppScript, no. You just go, I want to talk to Google Sheets. So spreadsheet app, you do things like objects instead of APIs and REST and HTTP. You just think objects. So in this case, I have a one-line application here, which is your hello world. So spreadsheet app dot get the current spreadsheet that I'm on dot get cell A1 dot set the value hello world. So that is a one-liner. I just broke it up into 4 lines so that people can read it more easily. But yeah, you save this, you run this. Oh, by the way, a lot of people don't know, the young people don't know why this is the save button. So it's kind of a running joke, but I'll let you elderly folks like myself explain it to you later. Okay, so anyway, that's the save button. When you run it, you're going to get your OAuth prompt. You have to give permission to this code to access your spreadsheets. So you have to go through that process. Once you click allow, and then you'll see hello world in your spreadsheet. So this is a lot shorter than getting the Python API client library, getting access to the Google Sheets API, going through the auth prompts. It's like that's like a 12, 13 line Python app versus 1 line in JavaScript. Okay, so it's very easy. It's actually, this is meant for the business developer, not the full stack developer. So it's meant to get things done quickly without a lot of lines of code. So I made a video on that if you're curious. But that's not a real app, right? So here's something that actually has real data. So it's an address. Let's blow up our app from 1 line to 4 and show you how versatile AppScript is. So I can, I've given separate talks like at the, local Google user group meeting just on AppScript alone because it's such an interesting platform. But check out this 4-liner. I'm going to connect to a Google Sheet as usual. This time I'm going to get cell A2, but instead of setting the value, I'm going to get the value, which means I want to pull this address out, save it. Then I'm going to say, hey, Google Maps, can you make me a map and put a pin on that address? And then line 4, hey, Gmail, can you email this map to my friend and maybe driving directions or walking directions so that they can come join me at the Google New York office for lunch, and then attach that to their email, right? I mean, this is an almost useful app, right? 4 lines that touches 3 different Google products, right? Google Sheets, Google Maps, Gmail, and it does something that could almost be considered useful, right? So that's pretty cool. And so even though this is just a 4-liner that is, can be demoable, but not really that useful, you can take this and blow it up into anything you want. Like maybe I want my salespeople to visit our 4 largest customers in Manhattan. You can update the code. By the way, this thing is so short that it won't take too much effort to be able to make it do this. I want to visit four customers and maybe give them walking directions or subway directions or whatnot. Same thing goes for user group meetings, like this one maybe, or book club or whatever, right? So you can say, hey, every month here's where the meeting is going to be. Use Google Calendar to put a meeting reminder into their calendars. Use the Gmail API to send out, at the beginning of the week, the user group meeting is this week. So you can actually leverage multiple Google APIs. So, all right, that is all I wanted to say about that. So let's wrap up by talking about a couple of quick demos of how to use both GCP and Google Workspace together in a serverless way that does useful things. So my colleague wrote this up, so I can't take the credit for it, but what he did was he added custom intelligence to Gmail by analyzing Google Workspace data using Cloud Platform. So what did he do? His motivation was that he says he gets a lot of email, and while Gmail does a great job of filtering out all the spam, even with his non-spam, there's only certain messages that he really cares about. So he wants to kind of filter them out. So his use case is, if you want me to read your email, you need to attach a picture of a bird with your email, okay? So I know it sounds funny, but let's roll with the example here and see how this app works. So what did he do? He wrote a Node app. Okay, so there's a little bit of JavaScript again. He wrote a Node app that says every single time an email comes to his Gmail inbox, it will send that message and send a notification to Cloud Pub Sub, which is our message queue service. What that will do is that will kick off a Cloud function, which will grab the attachments out of that email message. It will send them over to the Google Cloud Vision ML API to analyze the contents of that image. And if the labels that come back include bird as one of those, then that Cloud function will call the Gmail API and star that message. So without running any code explicit, without clicking on a button, without going to a web page, the next time he logs into his Gmail account, he'll see that some of his emails will have stars next to them, because this was a Cloud function that ran with the background event of receiving an email message. Okay? You know, again, not the world's most exciting demo, but you could build useful things. So you can make Gmail notify PubSub with that link there. You can have PubSub kick off a Cloud function, see the link there. But the main idea is that the Cloud function is the main orchestrator that talks to both GCP and Workspace APIs to be able to add this custom intelligence to Gmail. If you want to learn more about this sample, take a look at the blog post or go straight to the code. All right, this next example is my sample, and this is where I'm going from big data analysis all the way to slide deck using GCP tools from Workspace. So going kind of like the opposite direction that my colleagues' sample app did. So the main idea behind this app is big data is everywhere, and we've got to analyze it. There's lots of tools out there. One of them is Google Bigquery. If you've ever discovered that, it's a really, really cool tool. You basically can search multiple terabytes of data with just simple SQL and get results back in seconds. So it's pretty awesome. So let's say you've got a massive data mine of material and you're doing queries, you're perfecting your queries in the web app, and then you can kind of paste that directly into your code. So it's pretty cool. The only drawback is your output is either going to be looking nice in this command line in the web page, or you can download it as CSV. Neither of those things are very pretty to look at, especially if you want to show your manager. It's like these stairs here. You've done 80% of the hard work, but it could look better, right? You know what I'm saying? You could use these stairs, but it's not quite done. So what I want people to do is use the last 20%, finish the last 20% to make your data more presentable. Like, isn't a spreadsheet more presentable than CSV, or telling your boss to go to a web page? Right? And if you're going to be talking to the Sheets API, you might as well tell it to make a chart based on this data that you've just imported. And then if you're going to present to your boss anyway, why don't you just stick that data into a slide deck? In fact, why don't you just import that chart into the slide deck as well and just kind of like build it all out and have an entire slide deck? So really, you did the 80%. Why don't you just, write a little bit more code so you can go end to end and have, basically have it produce a slide deck for you. So this is an AppScript app, so it's written in JavaScript. So right now, again, it only supports JavaScript. You're sitting at the terminal, you're running it. I can't see. Oh yeah. So I'm running my AppScript app. It makes it calls Bigquery to do that query. The results come back. It goes into a sheet. I tell the sheet to make a chart, and then I create a brand new slide deck. I import the data and the chart, and boom, I have now gone from big data analysis all the way to exec-ready slide deck. And by the way, this is all less than 100 lines of JavaScript. If you strip out all my comments and blank lines, it is less than 100 lines of JavaScript. So pretty quick. I created a code lab for you so you can build this line by line. I also made a video and a blog post to go with it, but you can go straight to the repo if you want. I also gave a talk about these two apps that I just showed you at Cloud Next in 2018 and 2019. All right, a couple more demos and then we will be done. I know we're running short on time, so I'm going to go a little faster now. So this is from my summer intern in 2018. He wrote a Hangouts chat productivity tracker. It's basically a chat bot. He's a student, so every day he comes home from school, he starts like doing his job to help pay for his bills. So he's doing homework, he's registering that he's done some homework. So he basically sends a chat message to his bot, and he'll either say start or log, like I did my homework, or I started working for this third-party contract that I'm doing. So his App Engine app will store that data in Cloud SQL. So for every line item that the student has done, he registers another row in a SQL database. When he sends I'm done for the night, what it will do is it will take everything out of that SQL database. It will call the Cloud Natural Language API to analyze the text of all of the work that he's done, like he had lunch here, he had dinner here, he did homework here, he worked here. And so what that will do is that will stick everything into a spreadsheet so he knows how much to bill for his contract, how many hours that he spent on it. He can figure out how many hours he spent on homework and all this kind of stuff. So all that is to help improve his productivity. So here's the quick demo. Here's the chat room, his productivity tracker. He sends all those things, and the animated GIF, it goes really fast, and you may not be able to see everything before it disappears. But anyway, his app, you can take a look at the GitHub repo. He also presented this at the Google Developer Group user group meeting in Silicon Valley in August of 2018. And then the last app is his second project, which is using Google Docs as an IDE. So he was a student at Carnegie Mellon. He was a TA for courses that were meant for non-computer science students. And so he did, the professor didn't want the students to code using an IDE, which was too complicated. So he built a system where students can use a Google Doc as an IDE. So the professor will say, hey, you know what? I'm going to call a cloud function to create a new class. So please create editors. So he talks to the Google Drive API. It makes a whole bunch of spreadsheets. He adds the spreadsheet that he enters in all the students and their email addresses. Then he says, okay, now the students need editors. So it will go and grab the information out of the sheet. It will then call Google Drive and say, hey, make me a new Google Doc for every student. And then the students can go, they get notified that they can now code in their Google Doc. The student writes the code, and then the student calls the cloud function to run the code. And what that will do is that will read the code from the Google Doc. It will spawn a compute engine virtual machine, install Python, run the code, send the output back to Cloud Functions, which will then write that output directly into the Google Doc. So there's Python code he's writing, and then he's going to run the Cloud Function, and then after a second, the output comes back in, and then the virtual machine is killed. So it's kind of a crazy demo. But anyway, that's what he did. So that's another serverless tool that he wrote. And actually the repo hasn't been published yet. Unfortunately, he went back to school, and then nobody, and not even I, had time to go and clean up his code and put it on GitHub. But once it's published, it will be put in GitHub somewhere at some point, but I don't know when that's going to happen. So anyway, it's just a demo anyway. So to wrap up, what are some online resources? Serverless. There is some free, by the way. If you've never used Cloud Platform before, there's a $300 free trial that you can use for 90 days, as much as you want. There's also an always free tier. So most GCP products, I shouldn't say most, but many GCP products have some kind of monthly free tier so that you don't get billed unless you exceed that free tier. Serverless has specifically the serverless free tier. These are all monthly. I already told you that App Engine gives you 28 hours a day for free. That's front-end machines. If you want to do back-end machines, you only get 9 hours because those are like more horsepower machines. You get 1 gig of network and storage. I already mentioned that. Cloud Run and Cloud Functions, you get 2 million calls a month for free. You get 300, you get a certain number of gigabyte seconds free per month. You get a certain number of fractions of CPU usage per month, and then some network free per month as well. And then if you happen to be in higher ed or a student, professors can ask for credits for all their students to do homework. So there's a lot of free going on. Again, the free tier is meant to be fairly generous so that you can actually get something done, proof of concept or production app. All right, so to wrap up, why go cloud? Cloud computing is everywhere. You really should try to be using cloud just because you're expected in your job to know something about at least VMs. But serverless is even cooler than VMs because you don't have to think about how many VMs you need or things like that. All right. So serverless does let you focus on just your logic, whether it be apps, functions, or containers. And then if you actually use all of Google Cloud, like using both Cloud Platform and G Suite or Workspace, you can do kind of interesting things. Other APIs, so Workspace APIs, if you want to learn more about those, if you want to learn more about Firebase, I already talked about that. Data Studio is a free tool that lets you give any kind of data source and it builds a beautiful dashboard for you. That's also free. If you want to build voice-driven apps, there's the, like on the Google Home or Google Assistant, use the actions on Google Libraries and build Dialogflow apps. YouTube has APIs, Maps has APIs. Flutter is sort of like the Google flavor of React Native, where with one code base, you can automatically have an Android version, an iOS version, and a web version. Yeah, again, one code base, so you don't have to write separate versions, which is kind of a common problem that people have. So, and Flutter works well with Firebase as well. And some docs to get you started, GCP and Workspace. some code labs to get you started. So those are the App Engine, Cloud Functions, Cloud Run, Quick Starts, code labs to get you started. They're sort of complementary to the Quick Start, because a Quick Start is just a doc versus code labs, which are actually tutorials that you can follow step by step. There's a lot more code labs and videos and code samples. If you do know AWS and Azure but don't know GCP yet, we have 2 links for you to kind of compare and contrast. This platform has these products, this platform has these products, what do we have? And then if you want to just see serverless stuff, there's a special link for that. And that is it. Link to the slides down below, as well as the short link. Jeff also sent it out in the chat. Reach me at my Twitter. Oh, by the way, if you notice the progress bars down at the bottom, that is also AppScript. That is a Google. My colleague used AppScript to build a Google Slides add-on, because neither Google Slides nor PowerPoint, I believe, has progress bars. So he built one using AppScript, and so you can go to the short link there. My daughter says hello. She loves drawing anime, and there's that open Google Doc again. So that is it. I'm sorry I went a little bit over. But if we have time, I can take some questions. Otherwise, if we don't have time, then I'm happy to have Jeff collate all the questions. I can answer them over email, or you can also cut and paste them into this open Google Doc. So with that, I'm going to turn it back over to Jeff, and thank everybody for taking the time out for coming to my talk tonight.
Thanks a lot, Wes. We appreciate your talk. Great talk.
Yay.
So I think we have a couple questions in the Q&A. One is from AG. It says, how do I get my AppScript versioned in Git?
Okay, cool. Good question. Yes, so look up the tool called, there's a tool that lets you develop AppScript locally. Clasp, that's what it is, C-L-A-S-P. So just look up AppScript and look up Clasp, C-L-A-S-P. You'll get the GitHub repo for it. And what that does is think of it like kind of like Git, because what it'll do is it'll let you clasp, push, clasp, pull, so you can actually save your thing. You version it in Git, and then you use Clasp to upload it to AppScript, so that you don't have to edit in AppScript's editor. By default, it comes with an editor, which is what I had in my slides. But if you want to do it locally, use the Clasp tool. Okay, and that's how you save your stuff in Git.
Great. So we have some more questions. One from Hassan with 1 S. There's a Hassan with 2 S's next. But this one is it possible to use Zapier, if then that, or similar services with GCP Cloud Functions?
Good question. I am not sure. However, if either Zapier or if this and that has the ability to call an HTTP post or to send something to Cloud Pub Sub, then the answer is yes. As long as you can reach Cloud Functions, then it can happen, right? And of course, you just have to make sure that the security stuff is there. You probably have to adjust your security so that like other things outside of Zapier or IFTTT can't call your Cloud Function if you make it publicly available, or you allow list whatever you want to have done. Like you can also probably put your Cloud Function inside a VPC as well too. So I think it's possible. I just don't know how Zapier and tools like if this and that contact external services, but certainly if it can do HTTP post, then yeah, you can reach a Cloud Function.
Okay, great, thanks. So we have a fairly long question from Hassan with 2 S's. Mm-hmm. And okay, so
okay,
with
you don't have to. Yeah, you don't have to read it. You don't have to read it, Jeff. I can see it.
You got, okay.
But it's a great question. And the question is basically talking about the market, right? So obviously Amazon is first to market, so of course they have a lot of market share, right? It dominates over both Azure and ourselves. But if I were to look at it from, pretend I'm not an employee at Google right now, so I'm talking about just from a developer perspective. As someone, if I were to start a company today, I would not trust any cloud vendor. all right, because there's obviously downtimes throughout the year, no matter who you use, okay? So it doesn't matter how big they are, right? There's always downtime. Just because you're big doesn't mean you're more reliable, right? So if I was to start a business today and launch a service, I'm going multi-cloud, right? I'm gonna have my apps working on all 3 clouds so that if anything happened to one of the clouds, I'm not I'm looking for a single point of failure. I wanna have redundancy with my services, right? So it's worth exploring everything, right? You know, maybe a little bit interesting with Azure. Azure is very different because Microsoft, it's very easy for Microsoft to get customers because if you are doing, if you are a .NET stack, if you're doing C#, if you're .NET Core, and you are fully a Microsoft house using MFC or whatnot, it's very easy to go to Azure. Okay, so that's definitely a no-brainer, right? So that's good for exploration, but guess what? Azure also supports Python and stuff like that too. So it's not like it's only Microsoft things. They're much more open than before. All right, and then for Google, for us, we like to, we may not be the best at marketing. We may not have the prettiest this, prettiest that, but I think at its heart, Google is a technology company, and so I think we have more pride in our engineering work. So regardless of market size, I think we like to let our products speak for themselves. And if we can perform just a little bit better than the other clouds at a slightly lower cost, then we're going to continue doing that. Our current CEO of Google Cloud, not of Google overall, our senior VP. So he's Google Cloud CEO is a Google senior VP. So that's TK. So Thomas Kurian. He's spent like 20 some odd years at Oracle, and he is having us take a much more serious look at enterprises. So we are we're not focused just on startups anymore. We're looking at how do we keep Google from deprecating and shutting down services? How do we make things more long-term for enterprises? How do we think about security for enterprises more? How do we build out our VPC, VPN, VPS service so that it's more attractive to enterprises? So I think the market is great. I think it's always good to have more than one strong competitor in the area because you really want to have more choices, right? You don't want to be forced into using a platform just because it's the biggest, right? So I think it's worthwhile exploring everything, and really you should benchmark stuff. If you benchmark AWS and it works better than the other two, then yeah, stick with it. But if you find that Azure works better or GCP works better, then I would say why not, right? Especially if we can come in a little bit cheaper, right? So I think there's lots of reasons to be more flexible in terms of looking around. As a company that wants to be a leader in the cloud market, we're not trying to just copycat everything, right? We're trying to do our own innovations as well too. I think that one of our strengths right now is in our machine learning and AI stuff, because I think we're more of an AI first type company rather than a company based on services that we needed as a retailer. So I think we come at it from a different angle, right? So so I guess the bottom line to answer your question is, I think you should look at all clouds and ignore market share. Focus on services that you're looking for, focus on costs, and then focus on uptime, downtime, right? The other thing about our cloud is that we are carbon negative now. I think given the amount of carbon credits we have either purchased based on all of our wind farms and becoming a registered utility, we have erased our carbon footprint all the way to beyond the beginning of our company. So I think that's another good thing as well too, is that we're very focused on being very environmentally friendly. So anyway, so that's kind of like a long-winded answer to your slightly long question.
Right.
I know you have other questions we don't have time for, but feel free to drop that into my Google Doc, because I think those questions are pretty relevant, Hassan. I'd like to see some of those shared with other folks as well too. Jeff?
Great. So there's one more question, well, maybe more coming up, but from Padmini, are there APIs or a way to programmatically upload photos to Google Photos?
Yeah, good question. I believe Google Photos has an API, but they've recently they used to be a lot closer to the G Suite workspace team than before. So I think they recently sort of separated themselves from G Suite. So let me see if I can see whether they have an API. Yeah, so there is an API. So the API, let me punch that into, I don't know how to answer. Can I type an answer to your question. I can't. It says done. Let me just type it into the chat. So this is a link to the Google Photos API in the chat.
Is fine.
Yeah, so there is one there. All right, Hassan, you're welcome. Next, Thomas. I'm trying to beat you, Jeff.
Okay.
How does Cloud Run handle the scaling of containers? Definitely, it's done by traffic. Controlling, yeah, so one of the things that you cannot get with Cloud Run yet is hardware configuration, because I think that's what you're asking. So in that particular case, you may need to use a different version of Cloud Run or GKE. So Kubernetes Engine does allow you to select your hardware type, but I do believe we have a product. Look up Cloud Run for Anthos. I think that may give you the ability to choose hardware configuration, but the main idea behind fully managed is that you don't have to think about these things. So, I mean, I'm sure that if enough customers ask for it, at some point we'll probably add that. But right now, as far as I know, I could be wrong. We could have already launched something. I'm just not as up to date on every bit of news that comes out. But I do not believe that you can choose your Cloud Run instances based on hardware type at this time. Cool, John. Yeah, I think we do like a lot of sort of like the grunt work maybe better than some clouds do. I have to agree. So I have not used, for example, AWS Fargate, but from folks that I know who have tried that and compared it with Cloud Run, they felt that Cloud Run handled a lot more of the dirty work for them because, for example, you didn't have to go and do your DNS and talk to like Route 59 or whatever is the DNS hosting service on AWS. You don't have to do all that because it's handled for you. And I think the same thing may be true for Lambda as well too. We try to make it as sort of like turnkey as possible so that you don't think about anything other than your code. So yeah, so John, that is a good comment. Again, I don't like to, maybe I'm not the marketing person to really kind of like toot our own horns, but again, we like to let our products speak for themselves. But yeah, it's great. I'd rather see a non-Googler saying something about GCP being great at being good at multiple regions as well as handling a lot of the lower level stuff. But yeah, thanks for the comment.